So, what is the concept for normal type of problem in projection of solids? So, the concept here it is very simple. If the angle of inclination it is given with respect to HP and VP, if it is there with the base heads and axis, so you can see that one of the inclination will be there with the base heads and other inclination will be there with the axis. So then it is a normal type of problem. So it is very simple. You need to see in the question the angle of inclination either to the HP or VP if it is given with the base heads, and angle of inclination either to the HP and VP if it is given with the axis. Then the problem will become normal type of problem. Okay, normal type of problem in the projection of solids. And the same concept hold goods for the prism, pyramid and cone. Okay, the same concept apply. Problem number 5 from CAD solution book. So what is given in this question is a pentagonal prism, dimension 25 and axis length 60. So rests on HP on one of its edges of the base. So we have to get the edge on the right hand side. So which is inclined to VP at 30 degree. So here it is base edge inclination to the VP at 30 degree. Draw the projections of the prism when the axis is inclined to HP at 40 degree. So here it is a normal type of problem because angle of inclination they have mentioned with respect to base heads and the axis. Okay, that's why it is normal type of problem. Okay, now we will construct. First we are going to construct an XY line. So we have to construct a pentagon with respect to edge on the right side. Okay, so dimension 25. So now we'll take protractor and mark for 72 degree on either side. Okay, from that reference point we are marking at 72 degree and drawing a line of length at 25 to that marked angle point. Again keeping at the another end point, marking at 72 degree and drawing a line of length 25. Okay, now taking compass, measuring 25 mm length, so we have to cut 2 arcs from that reference point. So join it to complete the pentagon. So now we are going to mention the dimension 25. Now we write the namings, top face A, B, C, D, E and bottom face A1, B1, D1. So all the things written in bracket because bottom face not visible from the top view. Now we draw perpendicular bisectors by marking middle point of any 3 edges and drawing thin lines here. Okay, so herein we are drawing thin lines to find out the center of the axis. So remember it. So in prism we are drawing the thin lines. So O1. Now project it upward to complete the front view. Okay, the front view of a prism it is a rectangle. So here we have to construct a rectangle for a length of 60 mm. So first I am constructing an axis for length 60 mm. So we are going to construct a rectangle here. Now writing the notations, which are the ends visible, we write without brackets, and which are the ends which are not visible, so we are going to write down with the within the brackets. Now second, it is second position written with the base edge inclination. So base edge inclination is equal to 90 degree minus angle of inclination to the HP, that is 40 degree. So 90 minus 40 degree, it is 50 degree. So first I will take a reference point of T1 dash and C1 dash, taking protractor, marking at 50 degree. So mark at 50 degree and draw an angle line passing through that point. Okay, draw an angle line passing through that point. Now we have to cut the arcs for the base edge. Okay, so cutting the arc using compass from D1 dash to A1 dash, then D1 dash to B1 dash, then D1 dash to O1 dash. Okay, now writing the notations. So A1 dash, B1 dash and E1 dash, O1 dash. Okay, now you see these vertical edges are exactly perpendicular, so that's why from all these points we are placing the protractor and marking at 90 degree to draw the exactly perpendicular lines. Okay, so on all those reference point we are marking at 90 degree, so we have to draw perpendicular lines. So mark at 90 degree. So now, so draw a line of length passing through these points at a length of 60 mm. Okay, so draw a line of length passing through that point, length will be 60. So writing down the notations. So now we are extending the axis to show the angle for angle of inclination to HP. Extend the axis and check the angle. So here we are getting the angle of 40 degree. Okay, so inclination to HP it is 40 degree. Now project the lines, project it downward, project the lines, project it. Project it from this end also. Okay, first writing the notations for the bottom face. So here it is A1, B1, C1, D1 and E1 and O1. Similarly A, B, top face, we are writing for the top face now. E, B, C, D, E and O. So now we write the outer boundary line. So that is what the first step, writing the outer boundary line. Okay, connecting all the outer points to draw outer boundary line. So constructing the outer boundary line. Now visible face, the top face it is visible, that's why we get the continuous pentagon here. And then edge, you see A dash and A1 dash, that is also visible. So continuous line. Now you see bottom face not visible from the top view, so that's why a part of the pentagon will be written with a dashed line. Okay. Now the slant triangle, rectangular face D1 and C1 not visible from the top view, that why it is also dashed line. Okay. So part of the axis we show it. Now we have to draw an angle line for the base edge inclination. So base edge inclination will be drawing angle line like this. Inclination to BP 30 degree. So we have to make sure our third position diagram should not merge with the XY line. Okay. So when we construct, so from D1 to C1 we can cut the arc. We have to place the resting edge on that angle line. So it is merging, so we should avoid that. So we can take that angle line little lower here. So we will take the angle line so little lower here. Okay. So mark the reference point and mark for 30 degree. D1 is the reference point. From D1 to C1 we have to cut the arc. From D1 to D and C1 to C. Okay. So now it is reverse. D1 to C and C1 to D. Reverse we have to cut. That is D and that is C. Using compass we have to construct two pentagons here. So the length will be here remaining same, you just measure it. D1 and D1 it is exactly equal to D to E and C to B. Okay, C1 to B1. So those are all the same lengths. Okay, that's why I am taking that only one length and cutting the 4 arc, because all those 4 lengths are same. Now it is reverse. Okay, D1 to B1 if you measure, and that will be used for D1 to B1 and C1 to B1. Okay, that will be same. Okay, now from D1 to A1 and C1 to A1, that is also same length. Okay. So now you have to write the namings. It is E1, A1, B1, that is E, A and B. So now O1 we have to cut. D1 to O1 and C1 to O1. Same C to O and D to O we have to cut. Now we have to join all these points. Using scale we have to join. First we are going to join constructing a pentagons. So wherever the dashed line is there, so we are going to draw the dashed line. where there is a continuous line, we are going to draw with the continuous line. Okay. So part of the axis, you can show part of the axis. Okay. Now the nearest point to XY line, you see here it is D. Okay. So D is the nearest point to XY line. D is connected with C, and D is connected with E, and D is connected with D1. So these are the dashed lines. Okay. Now we write for the top face, and considering top face, we write the notation first. So writing down the notations carefully here. Similarly for the bottom face also we write the notations. Okay, first we are going to construct the dashed lines. You see this. So D dash to E dash, first dashed line. Okay. Then D dash to C dash. Then from D dash to D1 dash dashed line. Now everything, now remaining thing will be written with the continuous lines. So first we are going to construct the pentagons. Finally there is an axis. Okay, this completes the problem. Good morning all of you. Today we are going to start first problem in projection of solids. So with the prism. So we know that in the projection of solids we have to consider the right hand side reference for placing the base edge or the base corner. Okay, say just for an example, say you can see that this is our pentagonal prism which is having top face and bottom face. So you can see that this is our base edge. Okay, base edge, and this is our base corner. Okay, so we have to place it with the right hand side reference, and we know that our first position starts from the HP plane. Okay, so that's not the thing. So how the problem proceeds here, say consider, so this is our first quadrant. Say this is our pentagonal prism. Say I am placing with the right hand side reference. So right hand side reference means this side. Okay, right side. First position, drawing the top view, front view. You can see that you have two faces, top face and bottom face. Then drawing the top view, front view. Second position, it is a inclination, right side inclination. Okay, inclination to HP and then top view, front view. Similarly, inclination to HP it was already given, so it is inclination to VP. Okay, so understood, right? So it is what the inclinations, you can see that first position, inclination to HP, then inclination to VP, like this. So now we will proceed with the problem. Say in this problem we have to construct a square prism here, XY, VP, HP. So you can see that we have to construct a square prism. So of square prism of dimension 35 mm side, of base and axis length 65. Rests on HP on one of its edges of the base. You can see that. So say consider this is your square prism. So this is having, we need to construct with the base edge here. Okay. So here we have to construct the right hand side, we have to construct the base edge. So if you consider a square prism, the top view, okay, the top view of a square prism, it will be in square, correct? Square, which is having top face and the bottom face. That means you need to construct a square here, square of dimension 35. Okay. Okay, so we have drawn a square here. You can see that. So in the square prism, we have two faces, top face and bottom face. So top face will give A, B, C, D, like that. If you take this duster, okay, top face A, B, C, D, which is visible to us, and the bottom face, which is not visible from the top view, so will be giving A1, B1, C1, D1. That will be in bracket. Okay. So the top face notations are A, B, C, D. Similarly, bottom face notations are A1 in bracket, B1, C1, similarly D1. Okay. So now this is what the top view, and there will be an axis here. Okay. There will be an axis connecting the top face center and the bottom face center. We need to find out the axis of the center. Okay. So how to find axis? And we will draw the diagonals here. So diagonals will be thin lines here. Okay, draw with the thin line. So here exactly the top face center O and bottom face center O1, which is in bracket. Okay, now we know that we have to draw the front view. Say if you consider this, this is as your square prism, then we have drawn the top view. Okay, top view of it with the two faces. Say when we are looking in the front view, we will get a rectangular face here. Okay, rectangular face. For that rectangular face, they have not mentioned anything. Instead of that, they will be mentioning a 65 mm axis length. Using the 65 mm axis length, we can draw the front view. So we know that axis center connecting the top face and the bottom face, which is having an axis length of 65. So by projecting, okay, these are the projection lines. Direction. So using the axis length, 65 axis length, I am drawing the front view. We know that front view is a rectangle here. So remember it, front view of a prism. The front view of a prism in the first position is always a rectangle. So first I am drawing an axis line here. So axis line of dimension 60 here. So first I am draw an axis line. So which is having a dimension of 64. Okay. So using this axis length, I am going to construct the rectangle. Okay. So in the front view, we get a rectangle. Now we have to write the notation of it. So from the front view, we can see that So from the front view, so you consider this is your front view. So we can able to see from this front view B, B1, C, C1 visible, but A1 and D1 not visible, correct? So you can see that. So from the front view we can able to see these ends B, B1 and C, C1. So first I am going to finish with the top face. You can see that. So B dash it is visible, C dash that is also visible, but A dash it is not visible from the front view, and D dash not visible. You can see that this A and D not visible. Similarly, you can see that bottom face B1 dash which is visible and C1 dash which is visible, but A1 dash and T1 dash not visible. So similarly you can write so O1 dash and O dash. So that is one thing. So now we have done with the first position, top and front view. So second position, we know that we have to give the angle of inclination to the right side. Okay, angle of inclination to the right side. So second angle of inclination to the HP, here they have mentioned 45 degree. So what is the procedure here to do it? So first we will be taking this reference point of C1 dash D1 dash reference point. By taking this reference point, using the protector, you can keep the protector here exactly and mark for here in the right side from here 10, 20, 30, 40, 45. So mark for 45 degree angle and draw an angle line here. Okay, draw an angle line. So that is for 45 degree. After say first taking the reference point and keeping the protector and marking up for 45 degree and drawing an angle line, what is the thing? Next you have to take the compass and measuring from C1 dash to B1 dash, you need to cut dark. Okay, you have to cut dark. This is B1 dash and A1 dash, and the second arc you have to cut it from C1 dash to O1 dash. This is O1 dash. Okay, so after cutting this arc, so this is the length we require, right? So this is the length. So after this, say we have been drawn the bottom part, okay? So these vertical lines we have to draw. You see that these three vertical lines are exactly perpendicular to this base line, right? So you have drawn the base. So what you do, you take the protector, keeping at this reference point, you mark for 90 degree. So here you have to keep the protector and mark for 90 degree. Similarly, you have to keep the protector and mark for 90 degree. After drawing the 90 degree, this length we know it is 65. Using a straight line scale, you can draw a straight line here. Okay. So draw the straight line, and then run it using a scale. So this is B dash, A dash. This is O dash, this C dash, D dash. Okay. So now, so you can extend this axis because the angle of inclination it is given with the axis. If you extend this axis and measure the angle, you get exactly 45 degree. Okay. So now we will project it downward to complete the second position, top view. Okay, so for writing the notations, so you have to consider either the first face first or the bottom face. First I will consider bottom face here. You can see that. So here they are merging. This is A1, this is B1, this is C1, this is D1, and this will be O1. Similarly for the top face also, for this one also we can write. So this is A, and this is B, this is C, this is D, and this is A. Okay, so you have done the namings. Now you see the concept here. So here it involves 3 steps to construct the second position top view. First thing is you need to draw an outer line. Okay, remember it. So first we have to draw an outer boundary line. You can see that I'm starting from the A1 point. So A1 to B1, so that's an outer boundary line. Then B1 to C, okay, B1 to C. So it is another outer boundary line. Then from C to D, then D to E1. So this forms an outer boundary, that is A1 to B1, B1 to C, C to D, C to A1. So that is the first step, outer boundary line. Now, if the second step in writing the second question is seeing for the visible faces and visible edges. Say we are looking this thing from the top view, right? Looking from the top view. So you can see this in this diagram. We are clearly able to see the top face of this sphere prism, right? That is top face, it is visible like this. It is inclined like this. We are able to see from the top view this face. This face is exactly visible from the top view. So that is, so this sphere is visible. So we can join this ABCD. So that is the sphere we get it. So similarly, you can see that this edge B dash A dash B1 A dash, this is also visible. It is already written with the continuous. Okay, that's what the second step. Second step is writing the visible faces and visible edges. Okay. Now the third step is writing the hidden face and hidden edges. So you can see this bottom face not visible from the top. Okay, bottom face that is not visible, but already we have written a part of it. Okay, part of the sphere. But the remaining part we can show it with the dashed line here. Okay. So that's what a dashed line. So in this we cannot able to see this B1 and C1 here. Okay, that's what the thing. And then you can see that there is another this face also not visible, that is C1 D1 to D and C1 to C. But already we have written a continuous line. Okay, no need to show. Now we can show the axis line here. Okay, so that's what the axis line. Now in the third question you can see that. So you can see that one of its edges of the base which is inclined to VP at 30 degree. We know that in the normal type of problem, one angle of inclination will be there with the axis, okay, and then another angle of inclination will be there with the edges of the base, okay, base edge inclination. So what we do, so we have to draw an angle line here, okay, angle line here. So what we do, initially we draw a straight line here, okay, smaller line parallel to the XY, okay, parallel to the XY. So here I am marking the reference point. So you can keep the protector here, and mark for how much angle. So angle here given, that is 30 degree. So mark for 30 degree and draw an angle line. So draw an angle line. So this is 30 degree. So now what we have to do. So if say see that. So this is what the base is. Okay, this is CD1 D1. You can see in this problem also. We're inclining like this, inclining with the C1 D1. That's what the base is. So we have to take these base edge. You can see in the question also. So one of its edges of the base which is inclined to be at 30 degree. That is taking this D1 C1. So we have to make it resting on this angle line. Okay, how to do that? So I'll be taking first a reference point of D1 here. Okay, then measuring from compass, measure from D1 to C1 and cut the arc. This is dashed line, right? So D1 C1. So we have cut it. Now we can see in this question. So to this line, to this D1 C1 line, these two lines are exactly perpendicular, right? Exactly perpendicular. So what we do here, you take the protractor and mark for 90 degree on both sides, because these lines are exactly perpendicular to this. So taking the protractor, mark for 90 degree on both sides. Okay, you keep the protractor here, mark for 90 degree. Similarly, you keep the protractor here, mark for 90 degree. So after that, what we do, we will be drawing a straight line here. Okay, straight line here. Okay, straight line. So after that, what we do, we will take the compass, measure from D1 to A1. You can cut the arc. This is V1. Similarly, C1 to B1 you can cut the arc. So that is B1. Okay. Now similarly we have D1 to A1 also you can cut the arc. D1 to A. So D1 to A also you can cut an arc. Okay. Similarly C1 to B also you can cut the arc. Now from A to D also, by measuring from compass we can cut the arc A to D. Okay. A to D. Similarly from B to C also you can cut. Now we left with this O1 and O. You can see that you can cut that from A1 to O1 and B1 to O1 using the compass. Okay. So we are going to cut that. This is O1. Similarly, we have A to O, the R, then B to O. Okay. So after cutting all this arc, so using a scale, you can join all these things. So join all these things using a scale. So this is the second diagram we have copied to the third position. Okay. So now we have to complete the final position here. Okay. So how to do the easiest method here is, easiest method is, first I'll be drawing this, writing the notations of this top face and the top face, and then bottom face and the bottom face. Okay. First I'm finishing with the top face. You can see that. So draw a projection line till here only, so where it is the D dash, here we have this is D dash. Okay. Similarly, you can write for C dash also. C dash also we take it here only, right? So this is C dash. So similarly, you can write project only till where our any point you get it is A dash. This is B dash. So similarly we have this O point. Okay. This is O dash. Okay. So understood, right? Top face of this and the top face of this are getting here. Similarly, now we see the bottom face. So here the bottom face we have, this is D1. So here we have D1 dash. Similarly, this is C1 dash. Okay. And A1 is here. We are getting this A1 dash here. Similarly, we have this is B1 dash. And here it is exactly here we have O1 dash. Okay. So now we have done with both bottom face notations and top face notations. Okay, this is how we have to do it. Now for writing the final position, we have here concept that, so we have to see the nearest point to the XY line. So this is our XY line. The nearest point to the XY line, it is D here, correct? So you can see that the D is the nearest point. I will write here. So the D is the nearest point here. Okay. So nearest point is D. You can see that D is connected with which other? D is connected with C and D is connected with A. Okay, and D is connected with D1. It is like this. It is inclined like this. It is inclined like this. So this is what the D point. Okay, D point. So D point, it is connected with C. D is connected with A, and D is connected with D1. Okay, like this. D is connected with C. D is connected with A. D is connected with D1. Okay, these are the near connected points to it. So D is connected with C, and D is connected with A, and D is connected with D1. So these are the dashed lines. Okay, first we will finish with the dashed lines. That's all the concept. Take the nearest point. After taking nearest point, see that which are the adjacent points. D is connected with C, D is connected with A, D is connected with D1. Okay, so those are the dashed lines. So D dash to C dash. So this is a dashed line. So this is a dashed line. Then D dash to A dash. That's also dashed line. Then D dash to D1 dash. You can see that from here to here. Okay. So we have drawn with the dashed line. You can see that D dash to C dash, D dash to A dash, D dash to D1 dash. Then the rest of the thing, it is only with the written with the continuous line. First I am writing with the top face. Okay, the top face it is written. Similarly, the bottom face. So using a scale, you can do it. So you can see that A dash, B dash, C dash connected with the top square, bottom face it is done. Now the vertical edges, say from A dash to A1 dash, B dash to B1 dash, C dash to C1 dash. So straight vertical line using a scale you can do it. Okay, so C dash to C1 dash. Similarly we have B dash to B1 dash. Okay, so this is what we done. Now we have to draw an axis line. Say axis line from O dash to 1 dash. So we are showing the axis line. So understood, right? So how to write the final position here? It is first take reference nearest point XY line D. Okay, 1 point. D is connected with C, A and D1. These are the dashed line. First we have done with the dashed line. D dash to C dash, D dash to A dash, D dash to D1 dash. After that what we did? So after that remaining part we have written with the continuous line. Okay, so that's how we complete the first problem in projection of solids. The concept for beta angle in projection of solids. So what is the concept here is if the angle of inclination to the HP and VP, say both the inclinations to the HP and VP, if it is there with the axis, then it is a beta angle problem. Okay, beta angle problem in projection of solids. So the same concept it is related to the prism and pyramid also. So you have to see that if the angle of inclination it is there with the axis for both HP and VP, then it will be an beta angle in the projection of solids. The same concepts hold good for prism, pyramid and cone. Welcome to Engineering Visualization channel. Problem number 8. A pentagonal prism, 25 mm sides of base, 50 mm axis length, rests on HP on one of its corners of the base, such that two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projection of the prism when the axis of the prism is inclined to HP at 40 and VP at 30. So here first we have to construct a pentagon. In the first position we have to construct a pentagon, okay, of dimension 25 with respect to corner here. Given in the question, corner of the base, that means we have to corner on the right side. We know that in solids, right side is the reference for considering the base corner. Okay. Now here type of the problem. So which type we have to identify? Here the type of the problem here, the axis is given for the inclination to both HP and VP. So axis given means it is nothing but beta angle problem. Okay, beta angle problem, because axis is given for both HP and VP for the inclinations. Okay, now we are going to construct an XY line, okay, using the sketchbook sheets, okay, grid sheet, using grid sheet, because many of the students are using the grid sheet in VTU. So we will be considering the same thing here. First I will be drawing an XY line, horizontal line, exactly at the middle of the page. Okay, use the scale and draw a straight line. Okay, draw XY line and mention VP HP. Okay, because we are using first quadrant, so we have to mention this VP and HPs, remember it. And now we have to construct a pentagon. Okay, pentagon with respect to corner position, okay, which is of dimension 25. So using the scale, draw a line of length to 2.5 centimeter at 25 mm. Then use the protractor here, protractor for marking an angle of 72 degree. Outer angle we have to consider here, remember it, 72 degree exactly we have to mark. And now passing to that angle point from the reference end, we have to draw a line of length 25 mm, that is 2.5 centimeter from the scale we have to draw. In same way on this end also we have to mark an angle of 72 degree. Okay, and draw a line passing through that angle point, length of 25 mm, that is 2.5 centimeter. Draw a line. Okay. Now using the compass, measure 25 mm from the compass and cut the arc. You measure any one of the length here because all the lengths of 25 mm only. By keeping at that reference point, cut the first arc. Okay, and keeping at the second reference point, cut the first arc. Now you are getting a cut point. So join that arc cut point for this end point with a straight line using scale. Join it. Okay. You can give the naming for this. In prism, we know it is having two face, top face and bottom face. A, B, C, D, E is the naming of top face. A1, B1, C1, D1 and E1 is the naming of the bottom face. Okay, which is not visible from the top view. That's why it is written within brackets. Okay. Now show the dimension for one edge here. Here I am showing for one edge as 25 mm. Mention 25 mm here. Now we have to draw a perpendicular bisector here. I will be drawing two perpendicular. You know how to draw. So you need to draw a line exactly. First mark the midpoint of the edge and try to connect with the opposite corner using straight line. Okay, marking the midpoint and then try to connect with the opposite end. You will get the perpendicular bisector. Now you are getting the center, that is O1. Okay. Now draw the projection lines to construct the front view here. So here projection lines should be thin lines here. Make sure you should draw the thin lines. Okay. So in the problem given the axis height, axis 50 mm it is. So here the front view of the prism, okay, front view of the prism, it is a rectangular face. So here first I will be constructing a axis for a dimension of 50 mm. In same way you can draw here vertical lines for a length of 50 mm. Draw the rectangular face here. Okay. So show the front view dimension. Here front view dimension it is 50 mm. Mark the dimension of 50. Okay. Now we can write the front view namings. So from the front view, B dash, C dash and D dash visible, A and the E dash not visible. So B dash visible here, C dash visible, D dash visible, E dash and A dash in bracket. In same way for the bottom face, B1 dash and A1 dash not visible, C1 dash visible, D1 dash visible and E1 dash not visible. In same way axis center O1 dash and O dash not visible. So now we have done with the first position. Now we have to construct the second position. For the second position they have given inclination to HP 40 degree with respect to axis. Okay, but we will be constructing using the base edge here. Okay, so base edge inclination is equal to, we know the formula, 90 degree minus angle of inclination to HP. It is given 40. So 90 minus 40 degree means it is 50 degree. First I will be marking a reference point, that is D1 dash on a XY line. Okay. Then place the protractor and mark for angle 50 degree here, because base edge angle is 50 here. Now draw a line passing through that point. Okay. Now using compass we have to cut the arc. So the reference point here it is D1 dash. We need to measure from D1 dash to B1 dash. That is our first arc we need to cut on the angle line. Okay, measure it like this and cut it. And this point is nothing but B1 dash and E1 dash. Okay, A1 dash. The second arc should be from D1 dash to O1 dash for the axis. Okay, this is your O1 dash. Now the third arc we need to cut from D1 dash to E1 dash, that is C1 dash, you can say. So measure the arc length and cut it. Okay, now we can see for this base edge here, these vertical lines are exactly perpendicular. You can see this, all these 4 lines were exactly perpendicular to the base. So what we do, we are going to use the protractor and mark for angle 90 degree for all these reference points. Okay, place the protractor here, mark for angle 90 degree, fix up for the C1 dash here, mark again 90 degree, same way mark for O1 dash axis point, mark again 90 degree, then fix it for the last corner point, again you mark for 90 degree. Okay, now using scale, so we should be drawing for that 90 degree a length of 50 mm, because it is the same length we should copy here. So draw a line of length 50 mm. Count it 1, 2, 3, 4, 5. So till there you have to join. Same way for the axis also. To that reference point we have to draw an axis. Now we can connect from C1 dash to, from there you draw one perpendicular line for a length of 50 mm, and again for the D1 dash also you draw one line which is of length 50 mm. You can now draw the top face by joining all these points. Okay. Okay, now join the top face, write the top face notations: B dash, A dash, O dash, C dash and E dash and D dash. Okay, now we have to extend this axis to show the angle, because angle of inclination to HP they have mentioned with respect to the axis. So we need to show the angle for the axis only here. Okay. You can cross check the angle using protractor. So it is exactly 40 degree. Okay, that's what the angle given in the question, 40 degree. Okay, now draw the projection lines downward to complete the second position top view. So draw the projection lines here, vertically downward one by one from all these reference points. So draw straight lines. Okay, horizontally also we need to draw the projection lines. So use the scale properly and draw the horizontal lines. These lines need to be straight. Okay, so use the scale properly in order to draw the straight lines. Okay, now we can write down the namings for the second position top view. First I will writing for the bottom face, that is bottom face is A1, B1, C1, D1 and E1, and this is O1. Same way for the top face, A, B, C, D and E, and mention the O here. Now to construct this second position top view, we will be following 3 steps here. Okay, to construct or write, you can say, second position top view. So this concept will be holds good for all the prisms and pyramids. First step is writing the outer boundary line. So outer boundary line we have to draw, that is from A1 to B1, B1 to C1. We need to connect it using the scale here. So just draw the straight lines connecting it, A1 to B1, B1 to C1, then C1 to C, then C to D, then D to E, then E to E1, then E1 to A1. So this forms an outer boundary line. Okay. Now the second step is writing the visible faces and the edges. So we have to write or construct the visible faces or the edges. Okay, that is our second step. So visible faces and edges we will be constructing using continuous line. You can see as we are looking this diagram from the top view, this position. Okay, so as we look from the top view, so this face is visible, right? From the top view, this top face is visible. So which are the visible face? Here the top face is a pentagon. So we will be connecting all this with the continuous line here. Okay, you can subscribe to my channel and hit on the bell icon for the latest notifications and share it to maximum students so that they can be benefited. And this rectangular face also visible here, that is A to A1 and B to B1. So this also you connect it with a continuous line. Okay. Now the third step is writing the hidden faces. Okay. So constructing the hidden, or you can say invisible faces and edges by dashed lines here. So we need to use the dashed lines here. Okay. Say you can see here the bottom face of this pentagonal prism not visible, but already a part of the pentagon we have written with a continuous line. So here there is a concept called if there is a merging. Okay, if there is a merging of continuous line with the dashed line, we need to show only the continuous line here. Okay, if there is a merging of continuous line with the dashed line, we need to show only the continuous line here. We have to show the continuous line. That means we will be showing only a part of the pentagon with the dashed line here. You can say because already we have constructed a part of the pentagon with the continuous line. The remaining part, okay, the remaining part we will be constructing using the dashed line here. So try to join with the dashed line here. Okay. Now this head is also not visible from the top view, that is D dash and D1 dash. As we try to write in the top view, it will be from D1 to D. Okay, that will be the dashed line here. Okay. Now you can see here we need to write finally the axis here. Axis from O1 to O, but part of the axis I can show because there is already a dashed line there. Now the third position. Okay. Now the type of the problem here, it is beta angle, because they have given axis of the prism is inclined to HP at 40 degree and to VP at 30 degree. So for that angle line we have to draw like this. From their reference point I will consider and draw an angle line for 30 degree. So inclination to VP they have given in the question, it is 30 degree. So you need to make sure the space which is to be constructed here, make sure that the second diagram when we try to copy, it should not merge with the XY line or you should not leave the page. Okay, like that you try to draw the angle line. You should be here careful. Okay, when you are drawing an angle line, I think I should take the angle line little lower so that the diagram can be copied easily. So now from their reference point you can mark an angle 30 degree. Okay, mark for angle 30 degree. So from that point I'll be considering the angle line little lower. Okay, as I mentioned, you should not merge with the external or with the second diagram. Okay, draw an angle line for 30 degree. So this is having angle of 30 degree. Okay, now so we know that in the beta angle problem it is with respect to the axis we have to do. So there are two axes given, 50 mm front view, that is your first axis, and the second axis length is second position top view. So this is your second position. So we should be considering this length, okay, as your second length for cutting the arc and finding out the beta angle. This is your second length. Okay, so first axis length we have to use this one, that is 50 mm for cutting the arc. Okay, so this is your second length we should consider. Okay, second axis length. So first axis length given in the problem it is 50. First you take a reference point. Okay, take a reference point, that is your O. Measure the length of 50 mm. Okay, from the compass and cut an arc. So here axis length is 50 mm. So measure using compass and cut the arc. And to avoid the confusion here, we will be giving this as O2. Okay, after cutting an arc we should draw here locus line. Locus line we should draw here where exactly it has cut it, right? So draw an locus line. We'll be mentioning this as locus line. Okay, now the second arc we should cut, that is from O to O1. From the second position top view, from there to there we should measure using compass and cut the arc. We need to cut the arc on the locus line. Okay, so cut it and you can mention this as O1. Now connect from O1 to O. Okay, and then extend and find out the beta angle here. So using the protractor, so here the beta angle we will be getting, it is exactly 41 degree will get here, angle of 41 degree. Okay, so here the beta angle how much we got, it is nothing but angle of 41 degree. So we can mention. Now we need to copy the diagram. So this second position top view we need to copy on the O1. Okay, this one we should copy here. So you can see we have already O1. Okay, on O1 we have to copy the diagram. Okay, using the compass I'll be constructing this top face first and then the bottom face. So measure the length using compass from O to D here. O to D and O1 D1 both are having the same length. I'll cut two arcs here. First arc is from O to D. I'll mention that D, and same length is there, right? So I'll be cutting another arc without changing, that is O1 D1. That is also of the same length. Okay, you can do that like this. You can do O1 and D1. Okay, now using from O to A or O to E, you can say O to E and O to C. These two lengths will be same. We can cut two arcs here and here. Now from D to E, because you have the D point, right? D to E and D to C, these two lengths are also same. Just cross check it, same lengths. Now cut those first arcs, this one and this one. Okay, and we need to mention its naming here. So this is E point and C point. So mention. If it is not cutting properly, you can do it. Yes, now it is cutted. This is your point number E and this is point number C. Okay, now we have to cut the arc from O to A and O to B. These two lengths were same, OA and OB. So cut it, OA and OB. You have to cut. Now we can cut from D. Okay, we have that reference point, right? DA and DB, we can cut it from there to here and here. Can mention the naming as A and this is B. Now construct the pentagon. Connect all these points using scale here. So connect all these points here. We'll get the pentagon, and same way we need to do it for the bottom face also. Using O1 and D1 we need to construct the lower pentagon. So measure from O1 E1 and O1 to C1. Cut it here and here. Now from D1 to E1 and D1 to C1. Here and here you can cut it, and these 2 points you can mention as E1 and C1. Okay. Now again from O1 to A and O to B, these 2 lines will be same. Cut the arcs here and here. You can subscribe to my channel and hit on the bell icon for the latest notifications, and share to maximum students so that they can be benefited. So cut this arc. So finally we get it A1 and B1. Okay. Now again construct the pentagon here. So however it is there in the second position top view, we need to maintain the same thing. Wherever there is a continuous line, we'll draw with the continuous line. Where there is a dashed line, we'll connect with the dashed line. So construct the pentagon here. So in the same way we have to construct. Wherever there is a dashed line, we need to construct with the dashed line. Where there is a continuous line, we should be constructing with the continuous line. Okay. Okay. Now we need to construct the final diagram. For this we should be drawing the projection line upward. So to draw easily, you can see, consider top face here and here. So first you consider these top faces and write the notations, so that it will be easy to write the notations. Okay. Otherwise there may be chances of confusion. So you can see here from A I am drawing a line here, projection line. A and B, vertical lines. Straight lines you just draw. Okay, don't get confused that it should be merging or not merging. No need to consider anything. Just draw the horizontal and vertical straight lines. So these 2 points are nothing but A dash and B dash. Okay, now same way we will be drawing the projection lines from E and C. Okay, from E also you draw the projection line. That is E dash. In same way you draw the projection line from that C end. Okay, draw the horizontal line properly. That is your C dash. Okay. Now same way we need to construct D here. D and D dash, where it is merging, we have to see D and D dash merging at this point. This is we call D dash. Now finally O and O dash, we need to connect O and O dash. This is your O dash here. Okay. Now from bottom face also we need to do the same thing. D1 dash, draw the projection lines and connect and try to write the namings so that it will be easy. Okay, by following this procedure you can finish up the problem in less time. Okay, You can subscribe to my channel and hit on the bell icon for the latest notifications, and share it to maximum students so that they can be benefited. So particularly these problems are very useful to the first year engineering students throughout the world. They can benefit it by solving these types of problems. Can write the notations like this. Okay, and finally we have left with O1 dash. So you can project it this also. Okay. And this is your O1 dash. Okay. Now here to procedure to construct the final diagram, here it is. First you need to construct the base here. So here in this problem it is pentagon. So we'll be constructing a pentagon. If it is a square, you can construct the square. If it is hexagon, you can construct the hexagon. Okay. So try to connect all these points. You will get a pentagon here. Okay. Now we can see from the pentagon, so when we try to join the vertical edges, so vertical edges which are coming outside of the pentagon are continuous lines. If the vertical edge coming inside of the pentagon, that will be the dashed line. Okay, you can see from E1 dash to E dash. Okay, it is passing inside of it. So that's why we are going to draw the dashed line here. Okay, the remaining lines will be continuous here because all the lines were passing outside. I'll be drawing those lines. Okay, you can see here E dash is the dashed line. E, it is connected with A dash, that is your first dashed line. E, it is connected with D dash. E dash, A dash and E dash, D dash is the dashed line. Now all the lines here, that is vertical edges, we should be constructing with the continuous line here. Okay, that is the procedure here. You need to see whether the lines were going inside of the base of the pentagon or outside. Outside means continuous line, inside means the dashed lines. Okay, so that's what the procedure is very simple. You can follow these steps so that you can easily able to complete the final diagram. Okay, so finally the left one, it is the axis, that is from O1 dash to O dash, draw an axis. Guys, thank you all. Thank you for watching the video, and share it to maximum students so that they can be benefited. Thank you all. We see another problem in hexagonal prism. So you can see that we have to construct an hexagonal prism dimension 25. So hexagon of dimension 25, axis length 50 mm. So rests on HP on one of its edges of the base. So we have to construct an hexagon with respect to the base edge on the right hand side. Draw the projections of the prism when the axis here. So when the axis is inclined to HP at 45 and VP 30. So when the axis is given means it is an beta angle problem. Okay. So first we're going to construct XY line. This is VP, HP and Y. So we have to construct an hexagon here with respect to edge. Dimension 25. Okay. So it is 60. So now can take a dimension of 25 and we have to cut the arc. So this 25. Okay, again can keep the protector here, mark for again 60 degree. So here also mark for 60 degree. So here also we have to cut at 25, already we have cut it. Okay, so we have to join this. Okay, so we can write the notations now. A, B, C, D, E, F. Okay, bottom face notation B1, C1, D1, E1, F1. To find out the center of the axis, we will draw thin lines. Okay, thin lines, thin diagonal lines we will be drawing. Okay, so exactly at the center we have O and O1. Okay, now projecting this. So axis length is 50. So here so for the top face notations we'll write A dash, B dash, C dash, this is F dash, E dash and D dash not visible. Okay, similarly A1 dash visible, B1 dash visible, C1 dash visible, but F1 dash, E1 dash, D1 dash not visible, O1 dash, O dash also not visible. So now we will go for the base edge inclinations, that is 90 minus inclination to HPT is 45. So 45, that is we get 45 here. Okay, so here we have C1 dash and D1 dash. So we will keep the protector here, mark for 45 degree. Okay, first arc, second arc. Okay, so we can write this is our A1 dash, F1 dash, this is B1 dash and E1 dash, this is O1 dash. So these vertical lines are exactly perpendicular to this, so we can mark it, taking a reference of this we will be marking at 90 degree. Okay, Now drawing a line of length 50 mm. So now we can join this. Okay, so I can write A dash, dash, this is B dash and A dash, this is C dash and D dash, and this is O dash. So by extending this, okay, here we can show an axis. So if you measure the exact angle, you will get it here. It is exactly 45. Okay, 45 degrees. So now by projecting downward, so by projecting the lines from both sides, first we'll write the notations. Okay, so here, so this is A, this is B, this is C, this is D, this is E, this is F, and this point we have left. This point it is O. Similarly for the this is for the bottom face, right? A1, B1, C1, D1, E1, F1 and O1. Similarly for the top face also we can write. Okay, so this is A, B, C, D, E, F. Okay, this point is O. Okay, we know how to construct the second position top view. That is, first we have to construct an outer boundary line here. Okay, first we have to construct outer boundary line. This is connecting here, and this outer boundary line it is done. Now visible space, as it is looking from the top view, we are able to see this face and this. Okay, so the top hexagonal face it is visible. So we write the hexagon here. Okay, and this rectangular face also visible from the top view, F1 and A1 visible from the top view, but this base of the hexagon not visible from the top view. So part of it is written with the dashed line. Okay, and then this rectangular face C dash, D dash and C1 dash, this rectangular face also not visible, so we can show a part of it here. Okay, and we can show an axis here, so this is an axis line. Okay, so now, so this is an angle of inclination to VP, it is 30 degree, but so this problem it is an beta angle. Okay, so here we have, this is having 50 mm, right? So this is your first axis length, and this length, okay, from O1 to O, this is your second axis length. Okay, considering these two axis length 1 and 2, we can, so 1 and 2 we can done the third position. So here in, we will take here the axis line here. So this is mark reference point, then marking reference point, we'll be marking at this 30-degree angle line. Okay, so axis line it is drawn, it is 30 degree. So what is the procedure is, first we have to take this 50 mm axis length. Okay, you can extend this. First I will take a reference point of O, and I will be measuring this axis length first, that is 50 mm, measuring 50 mm. And cut the arc. So this point it is O2. So after drawing this point, you have to draw an locus line here. Okay. Then after that, you have to cut the arc from this, from O to O1. And the arc. So this is O1. So now you join this then axis and then extend and find out the beta angle. So here for this we are getting an beta angle of around 50 degree. Okay, now we have to transfer the diagram. Okay, this diagram here. So here you can see that we have 2 points O and O1. Using these 2 points we have to construct the rest of the diagram. So here we have this O point, so I can construct this from this O and O1. You see that O and O1, so I'll be constructing the rest of the diagram. So from this O point, O to F and O to A, these 2 points are same. We'll be cutting 2 arcs. Okay, then I'm cutting from this O1 point to F, O to F and O1 to F. Okay, so this point it is F and this is A. Similarly, you can cut this O to E and O to B. You can see that these 2 lengths were same. Okay, so from this point only you can cut it. We have 2 points. Okay, F to E and A to B. C, this is B. Again we can cut this O to D and O to C. Okay, now reverse it, F to D and B to C. This point it is D and this point it is C. Similarly we have to construct this one from O to D and O to C1, O1 to D1 and O1 to C1. Okay, and from here again reverse it is O1 to D1 and O1 to C1. So this point it is D1, this it is C1. Now O1 to E1. Okay. Now from D to E1. This is E1 and B1. Again from O1 to F1 and O1 to E1. Okay. Now from here E1 to F1. Okay. Then B1 to E1. So this is F1 and this is E1. Now, so we have to join this. Then from these two hexagons, first we complete these two hexagons, then we'll join vertical edges. Okay, so now we have to finish the final position. To construct the final position, here we have to consider two nearest point. Okay, so before that, first we construct this final notation, this one and this one, top face of this front view, top face of this. Okay, first horizontal line projections. Okay, now we will do one by one. So till here, so this point it is A dash. Now here we have, so this point is B dash, and similarly we have this point, and this point it is C dash. Okay, C dash, and D point it is this is D dash, D dash, and we have this point is F dash, and exactly the center we have this point, this is O dash. Similarly for the bottom face also we do it. Okay, so this point it is E1 dash, B1 dash, C1 dash, D1 dash. This point is E1 dash, and this point it is F1 dash, and we have this point it is O1 dash. Okay, so here you can see that the nearest edges are E and D, so I will write here nearest 2 points to x5. Okay, so that is E and D. So E point, you can see that is near connected to E to D and E to F. Okay, and then E to E1. Okay, E to E1. Similarly, we have D. D is connected with E, D is connected with C. Okay, and D is connected with D1. So these are the dashed lines. Okay, first we are going to complete the dashed lines here. Okay, E to D, that is E dash to D dash. Okay, and then E to F, you can see that. Okay, E to F. And then E to E1, E to E1. Okay, now we have D2 is done, D to C. Okay, now D to D1. Okay, so these are the dashed lines done. Now we will complete the base of the hexagon. Okay, so this base also will complete it. Okay. Okay, now from A dash to A1 dash, and then from B1 dash to B1 dash. Okay, now finally we have axis. Okay, so this is how we complete the problem. Today we are going to start a new problem on a square pyramid. So you can see the problem. So you have to construct a square pyramid of dimension 35, base head dimension, 65 mm axis length. Okay, rests on HP on one of its edges of the base. That means we need to construct a square with respect to the edge here. Okay, so first we are going to draw an XY line here. Okay, square of dimension 35, you have to 35 means 3.5 box here. Okay, so here in the slant edges will be thick lines. Okay, because these are slant edges. Okay. So I can write A, B, C, D, O and O1. So I can show the dimension here on one side. So it is 35. Okay, now projecting okay, here axis length is 65. Okay, 65. Take here 65 using the scale. here. Okay, the front view of a in pyramid, it is a triangle, you know it. Okay, so here B dash visible, A dash not visible, C dash visible, D dash not visible, O1 dash in bracket, and O dash. So here we'll take base edge inclinations. It is 90 minus angle of inclination to HP, it is 45. You can see that. So that is 45 degree. Okay, here take a reference point of C dash and D dash. So using protractor, we want to mark 45 degree. So here angle line. So now using compass, we have to measure this length from C dash to B dash. The first arc, second arc from C dash to O dash. Okay. So you can write here B dash and O dash. This is O1 dash. Okay. Now using compass, second arc from C dash to O dash. So you can join it. Okay, so we have to join here. Okay, so this point we need to join. Okay, and we have this axis. So we have to draw an axis here. So by extending this axis, if you measure the angle, so that will be exactly 45 degree. Okay, so this is O dash. Okay, now projecting the lines vertically downward. B, C, D, 1, O. So first we construct outer boundary line. C to O to D and D to E. So this forms an outer boundary line. Now here triangular face B dash, A dash, O dash, triangular face visible from the top. Okay. So it is visible. Okay. Now we can see that this square D is not visible from the top. So that's why it is a dashed line. Okay. Then finally we have an axis. So I can show it. Now angle of inclination to VP is 30 degree. I'll draw a parallel line here. Take a reference point. Here I will mark 30 degree. Okay. 30 degree. So this is what the resting is, not visible from the top. We'll take this. Okay, so for the angle line we are going to draw the angle of inclination line here. Okay, it will be convenient. Cut D point. This is C. Okay, now from C to B, and D to A. Next it is reverse. At this point it is boven. From D to O. This is O. Okay, now we'll join these lines. So this is dashed line. Okay, and finally we have an axis. Okay, now projecting the lines to construct the final position. Okay. This is O dash. B dash. This point it is C dash, and D dash we have this D dash, and finally we have this O dash. Okay, the concept for constructing the final position in the pyramid is, first we have to construct the base, that is here in the base it is in square. So first we are constructing a square here. Okay, then we draw the slant edges. Say the first slant edge I am drawing from A dash to O dash, next from B dash to O dash, third from C dash to O dash. You can see that with respect to this base, if the slant edge is passing inside of it, inside of this square, the base, we can say that will be n dashed line. Okay, the dashed line, and finally we have an axis. So this is how we complete the problem. Today we do another problem in pentagonal pyramid. So the problem number it is 23 in CAD solution book. So in this problem they have given pentagonal pyramid dimension 25 and axis length 50, rest on HP on one of its corners of the base. That means the first position starts from the corner on the right hand side, and then you see that draw the projections of the pyramid here. When the axis of the pyramid it is inclined to HP at 40 degree and to VP at 30 degree. So angle of inclination it is there with the axis for both HP and VP, then it is an beta angle problem. Okay, it's an beta angle problem. So first we construct an XY line here. Okay. First we construct an XY line here. XY, HP. So pentagon we have to construct, dimension 25. Okay. Now the angle we have to construct 72 degrees. Okay, 72 degrees. So I'll be drawing a line of length to this. 25. Very also. So now using compass, I will join it. So pentagon it is constructed. Now perpendicular bisectors we have to do. So for that we will be marking exactly the middle points of all the edges. Okay. After this, these edges. Okay, you have to keep only the slant edges here. Okay. Keep only the slant edges here. A, B, C, D, E, this is O and O1. So now we'll project it front view. So for the front view they have given dimension of 50. Okay. On the axis line. So A dash in the B dash, C dash, D dash in the so 1 dash, 1 dash, this is D dash. So now second angle of inclination it is 40 degree. So we will go to base edge inclinations. That is 90 minus angle of inclination to HP, that is 40. So we will get 50 degree. So I will take first a reference point of here, D dash. Marking it 50 degree. Using compass. Start. Second arc. third arc. Okay, so we will give the namings dash, C dash, and A dash. Okay, so we are going to erase this part using compass from T dash to O dash first arc. Second from this B dash to this. So now I have to join it. So there is an axis here. And a straight line. Okay, so we are going to extend this axis. We can show the angle here getting exactly 40 degrees. So projecting downward, okay. O dash, I can write the namings here. A, B, and this is we have 1. C point is this. This is D. This is E. And this point is 1. Okay, so D is not visible. So first we construct an outer boundary line. Okay. Now the triangular face, this A dash, B dash, O dash, visible from the top view, that is triangular face. So ABO, it is visible from the top view. Okay, now this is pentagonal base, not visible from the top view. So part of it we are going to show with the dashed line. Okay, then we have finally from to here part of the axis, so I can show. So this is a beta angle problem. The first axis line we have to use this, and second axis line we have to use this. So how much we are getting this? This is around 40 mm. Okay, 40. So now it is in beta angle problem. First, so I can take here draw line and here reference point. Angle of inclination, that is 30 degree. Okay, first reference point I will take, that is O, measuring 50 mm. Is O2, then one focus line. Again we measure from this is 1. So we will get the angle between here. So we are getting an angle of 41 degree. Okay, so now we have to copy the diagram. So this diagram we have to copy here. Look at this diagram. So we have 2 points here. You can see that on the same point, then we have O1 to D. Next from here, O to D and O to C. Next from this D to this point we have this point we have D, this is B. So we are going to join it. From here to here is the dashed line. So we are going to show with the dashed line only here. Okay. Now we have to project it upward. Dash, G dash, and finally we have this is C dash, one dash. So how to construct the final position? First we construct the base of the pyramid, right? That is base. Here we have pentagon. So pentagon we will be constructing. Okay. Okay. Now we have to construct the slant edges. With the slant edges passing outside, that will be continuous lines. You see that from B dash to dash. C dash to dash. You can see from here, from E dash it is passing inside. That's a dashed line. Similarly from this D dash also. So it is passing inside of it. That's why dashed line. Finally we have an axis. So we can show an axis. So this completes the problem. We see a different type of problem in pyramids, that is slant edge and slant triangular face. Okay, in this type of problem they will be not mentioning second angle of inclination, that is inclination to HP, they will be not given. Instead of that they will be mentioning slant edge, resting on the slant edge and slant triangular face. In this problem another thing is that they also don't mention the first position also. So how to identify the first position? If they mention slant edge, means the first position will be starts from the corner. Okay, if they mention slant triangular face, means your first position starts from the edge. Okay, base edge. So this is how you have to identify in the slant edge and slant triangular face. Remember, they will be not mentioning second angle of inclination to HP. Instead of that, they will be telling resting on the slant edge or slant triangular face. And they are not mentioning the first position also, it is resting with the base edge or base corner. So we have to identify from these words. Say slant edge means first position starts from the corner, slant triangular face means first position starts from the edge. Okay, so problem number 24 from CAD solution book. So in this problem, it is a problem from projection of solids. You can see in this problem what they have given: hexagonal pyramid of dimension 25, sides of base 50 mm axis length. They mentioned rest on HP and one of its corners of the base. So first position start from the corner, okay, with respect to the right side, such that two base edges. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degree and appears to be. You can see that if they are given appears to be means no beta angle. Okay, no need to find out the beta. Now we are proceeding with the solution. So first I am going to construct XY line. Then after that I am going to construct VP, HP and Y. So here you can extend this. So here first position starts from the corner. So dimension 25. Mark it 60 degree. So we have to mark at 60 degree here. I am drawing a line of length 25. Okay. Again we have to mark at angle 60 degree. Again drawing a line of length 20, so 25. So again we have to and drawing the line of length here. Now finally, so we can join. So we can show the dimension on one side. Give the naming A, B, C, D, E, F. Now drawing the slant edges, here inside lines has to be thick lines, okay? Inside lines has to be thick lines in case of pyramids. So remember it. So in case of prism, we are drawing the thin lines to find out the center of the axis. Okay. This is O and O1. Now projecting the lines. So from here we have to draw an axis of length 50. dash, B dash, and F dash. This is O1 dash, C dash, and E dash, and D dash, and this is O dash. Now first we are going to take E dash here. So here we write base edge inclination. Okay, so base edge inclination it is 90 degree minus angle of inclination to HP given 40 degree. So 90 minus 40 means it is 50 degree. So we have to incline this at an angle of 50 degree. Okay. So first star, vertical, second arc, third arc, fourth arc. So now you have to write the namings: U dash, C dash, F dash, O1 dash, C dash, B dash. Okay. Now measuring from here, so if you measure this angle, you have to get just like exactly 40 degrees. So this length we have 50 mm. Okay. So this is O dash. Now projecting downward, so we have to construct an outer boundary line first. Okay, outer boundary line. So first we have to construct the outer boundary line here. Okay, now these edges are visible. Okay, F2 is also visible and this also visible from top view, but this base it is not visible, so that's why it is written with the part of it is written with the dashed line. Okay. Again from D dash to O dash that is also not visible, so dashed line. And then A to O, that is also visible. You can see that A dash to O dash also visible. Now take a reference point. So angle of inclination to BP 45 degree. Take that. is 55 degree. So appears to be problem. No need to find out beta angle. So first is the O point. Now measuring from O to A. First measuring from O to O1. Okay, measuring from O to O1. Next measuring from O to D. So these points we are getting is D. So D point is not visible. This is O1 and this is G. Okay, we have 3 points here. A to F. Okay. Then reverse it is from here D to you can see this strength also same. It is from D to E. So we can join F, E, B, C. So now we write the final position. Okay.
Tilak, Sumut, Harish ಬಂದಿಲ್ವಾ? Harish DNA submission ಯಾವಾಗ 23rd 26 is the last date. ಇವತ್ತೆಲ್ಲ complete you take all this coordination of that and complete make it ready. You have to get it the signature from the principal and your hತ್ರ.
Chairman or secretary and
ಅದನ್ನೇ ಅದು ಹಾಕ್ಸನ್ ನಾನು ಫಸ್ಟ್ ಯು ಟೇಕ್ ದ ಪ್ರಿಂಟ್ ಔಟ್ ಆಫ್ ದಟ್ ಫಸ್ಟ್ ದಟ್ ಪ್ರಿಂಟ್ ಔಟ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಏನೇನು ಕಂಪ್ಯೂಟರ್ ಆಗಿದೆ ಅದು ತಗೊಂಡ್ಬಿಟ್ಟು ಎಸ್ ಅಂದ್ರೆ ಈಗ ಸಬ್ಮಿಟ್ ಮಾಡಬೇಕಲ್ಲ ಸಿಗ್ನೇಚರ್ 15 ಅಕೌಂಟ್ ಸೆಕ್ಷನ್ ಸೈನ್ 25% ಅದೇ 25% ಕಾಲೇಜಿಂದ ಹಾಕಬೇಕು ಸ್ಯಾಂಕ್ಷನ್ ಆಗಿದೆ ಅಂತ ಈಗ 25 ಲಕ್ಷ ಸ್ಯಾಂಕ್ಷನ್ ಕೊಡ್ತಾರೆ ಕಾಲೇಜಿಂದ 25 ಅಂದ್ರೆ 25 ಕೊಡ್ತಾರೆ ಅಷ್ಟೇ. So you all of you should be ready because there is no time. ಇವತ್ತು 23 ನಾಳೆ ಇವತ್ತು ನಾಳೆ ಒಳಗಡೆ ಸಬ್ಮಿಟ್ ಆಗ್ಬಿಡಬೇಕು ಅಷ್ಟೇ.
ಆಗಿದೆ ಸರ್, ಅದು ಚೆಕ್ ಮಾಡಿ
ಚೆಕ್ ಮಾಡ್ತಾರೆ.
PPT ಮಾಡಬೇಕು.
ನಿಮ್ದು ಒಂದು PPT ಮಾಡಬೇಕು. ಇವ್ರು ಬೇಕಾಗಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಆಲ್ರೆಡಿ ಇವ್ರು PPT ಕೊಟ್ಟಿದ್ದಾರೆ. PPT ಇನ್ ದ ಸೆನ್ಸ್ ಏನಾಗಿದೆ ಅದೇ ಸೇಮ್ ಥಿಂಗ್ ನೀವು ಏನು ಮಾಡಿದ್ರೆ ಅದೇ ಸ್ವಲ್ಪ ಹೇಳಬೇಕು, ಈ ಥರ ಮಾಡಿದ್ದೀವಿ ಸರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಎಸ್ ಅಂದ್ರೆ ಇಲ್ಲ ಅಂತ ಅದು ಇಲ್ಲ. Just you have the responsibility for this one. You have to take care of the dividend. They have to complete by today and tomorrow. ಇವತ್ತು ನೀವು ಹಾರ್ಡ್ ಕಾಪಿ ನನಗೆ ಅಲ್ಲಿ ಹೋಗಿ ಸೈನ್ ಮಾಡಿಸ್ಕೋಬೇಕು.
ಇದು ಹಾರ್ಡ್ ಕಾಪಿ ಸರ್.
ಸೈನ್ ಮಾಡಿ ಇದಕ್ಕೆ ಪ್ರಿಂಟ್ ಬೇಕಲ್ವಾ?
Okay, this completes the problem. You can like the video, subscribe for the channel and hit on the bell icon. So now we are going to discuss problem number 31 in CAD solution book, question bank solution book. So this problem we are starting with the slant edge. Okay, you can see in this problem we have to construct a square pyramid of dimension 35 and axis length 50. So rest on HP on one of its slant edges. As I mentioned, if they given slant edge means our first position starts from the corner. Okay, first position starts from the corner here. Okay, your first position starts from the corner here. Draw the projections of the pyramid when the axis, you can see that when the axis is given, and they have also mentioned appears to be. So if they mention appears to be, no need to find out the beta angle. Okay, appears to be if they given means no beta angle. Okay, no beta angle. So herein we have to construct a square of dimension 35 with respect to corner. Here slanted means for corner we have to start. Okay, first I'm going to write an XY line. Okay, so so first I'm going to take a reference point here. Somewhere here I will take. Okay, here I will take reference point and I'm going to mark 45 degree on both sides. Okay, 45 degree, and here also 45 degree. So now I'm going to draw a line of length 35 from this end. Okay. So 30, 35, here I will end. Similarly here also. Okay, so it is done. So now using compass, measuring 35. So we are going to cut the arc. So it is around here getting. Okay. So we can give the name A, B, C and D. So we will write the slant edges here. Slant edges we have drawn. And we can show, we have to show the dimensions here. So now project it upward to complete the front view. So front view axis length we have, it is 50. So A dash, B dash, C dash. But D dash not visible, O1 dash also not visible, O dash also not. So in this problem we have to make it this resting on the, this is our slant edge. We have to make it this slant edge resting on this XY line. Okay, that's what the problem here. C dash, from C dash to O dash you can cut the arc. Dash again from C dash to A dash. So we are going to cut the arc. Then again from this O dash to A dash. Okay. So we are going to join this. This is A dash. also here. So now we'll project it downward. So you can write the names. This is A, B, C, this is D, this is O1, and this is A2. First we construct the outer boundary line. This top face, it is visible, okay, square, it is visible from the top view. Sorry, this is B dash and this is C dash, this is C dash. Okay, this see that A dash, this slanted it is visible from the top view, so it is continuous A to O, but from the C dash it is not visible. Part of the we are showing the dash line. Okay, so it is now it is appears to be, so appears to be means no bit angle, so we replace it with a reference point here. And here we have 55 degree. So first I will take reference point of O here. Next from O to C we have to do. We go to C. I see this from C to O1. Then O1 to E1. In the same line we are having it. E1 and this is A. Now put in the arc. This is D, this is B. So now we can join it. Part of the dash line you can show here. So now final position, dash, and this. Finally we have one dash. First we construct the same concept and pyramid. First we construct the base of the pyramid. Okay, no slant edges just passing outside, and this also passing outside, and this also passing outside, but from here D dash to O dash is passing inside. That's why dashed line, and finally we have axis. Okay, so this completes the problem. Another problem in from the CAD solution book, on the slant triangular face on the hexagonal pyramid. You see in the problem, hexagonal pyramid dimension 25 and 50 mm axis length given, rests on one of its slant triangular face. So slant triangular face means our first position starts from the base edge or the side. Okay, so draw the projections of the pyramid when the axis appears to be. So axis appears to be means no beta angle. Okay, so when the given appears to be means no beta angle. So here first we have to construct an hexagon with respect to edge here. So edge we have to construct hexagon with respect to edge. So 25 dimension. So marking at 60 degree. So 25 here again. So you have to mark it 60 degree. Again we have to mark 60 degree. So 25 and again here. So marking it 60 degree. Finally we have so constructed second A, B, C, D, E, F. Now the slant edges. Slant edges we have drawn. So here, so 25. Okay, this is O1 on the front view. So front view axis length we have 50. So naming dash not visible, B dash, C dash visible, F dash not visible, D dash visible, E dash not visible, O1 dash, O dash. So on the slant edges, so we have to mark D dash and E dash. So measuring the length from compass from D dash to O dash. From D dash to A dash, and again from the O dash to A dash. So join it. C dash, F dash. Okay. Now drawing the second position top view. inclinations here. This is E, this is D. This point we have C, and this point is B. This is E, and this is F, and centrally this one O1, and it is O. So first we are constructing an outer boundary line. Okay, so outer boundary line is on, and hexagonal face it is visible from the top view. So actually this is connect here, and this part, and this is D. Okay. So and this triangle of A dash B dash O dash visible from the top view. So it is a continuous triangular face. Okay, this bottom face, you see that with this bottom triangle of face E dash D dash O dash not visible, so that's why it is written with the dashed line. Okay. And finally we have an axis. We will show an axis. So no bit angle here. So because appears to be, they have mentioned angle of inclination to VP is 45 degree. So take a reference point of O. Next from O to O1. So we can cut the arc. This is O1. Now using from O to A, exactly the same length. So here we have to cut first arc, second arc. Next from O1 to A and O1 to B. So this is A and this is B. Okay. Now we have O to F. Constructing hexagon. So here from this point we have dashed line. So final position we have to do so dash here. Small D dash. This is D dash, D dash. C dash. This is 1 dash. So first we are going to construct a hexagonal base here for the pyramids. Slant edges. Okay, here two slant edges from F dash to O dash. It is passing inside, and from here A dash to O dash also passing inside. Finally, we have axis, so we can show the axis. So this completes the problem. Okay, today we are going to start problem number 43 from CAD solution book. Okay, it's a cube problem. So the dimension is given 40 mm side, rest one is on an edge, so which is inclined to VP at 30 degree. Draw the projection in the lateral square face containing the edge on which it rests makes an angle of 50 degree. First we have to construct a square of dimension 40. Okay, we will draw thin lines here to connect the center of the axis. Here is the naming A, B, C, D, top face, A1, B1, C1, D1, O, O1. Front view we are getting this, front view also 40 mm. B dash, A dash in bracket, C dash, D dash in bracket. Similarly A1 dash, B1 dash, C1 dash and D1 dash, E1 dash, and this is O dash. Lateral square face containing 58 means we have to do base edge inclination here. Base edge inclination is equal to 90 minus 40, that is 40 degree. So here can take a reference point of C1 dash and D1 dash. Here marking at an angle of 50 degree. Measuring the length from here to here cut the arc. This is A1 dash, B1 dash. So this is O1 dash. Okay. Now we will be marking at 90 degrees. So we have to draw a line of length 30 here, 540. So now we can join here. So B dash, A dash, this is O dash, C dash, and D dash. So if we extend the axis, find out the angle of inclination here exactly 50 degree. Okay. So now projecting downward, so we can write here this is E1, B1, C1, D1, this is O1. Similarly we have this is A, this is B, this is C, this is D, and this is O. So first we construct an outer boundary line here. Outer boundary line we are constructing. In this top face it is visible, ABCD top face. Okay, in the bottom face here it is C1 and D1 not visible from the top view, so that's why D1 and C1 it is in bracket. And finally we have an axis, so we are showing it. Now inclination to VP here 30 degree. So take a reference point here, mark for 30 degree. You have to take this reference point of D1. From D1 to C1, cut the arc. So this is dashed line. We'll be showing with the dashed line. Okay. So now suppose these points and be marking it exactly 90 degrees on either side. So now we are going to cut the arc. So we can join it. So this is A, B, this is A1, B1. So this is D, this is C. This is A1 and this is B. So this remaining thing we are going to rub it. D dash, this is C dash. O dash. Okay, finally the bottom face. This is 1 dash and this is we have B1 dash, B1 dash, this is D1 dash and this is C1 dash. So okay, we take a nearest point. So nearest point equivalent is D here. So D connected with C, D is connected with A, D is connected with D1. So these are the dashed lines. Okay, so understood, right? So from D to C, that is from D dash to dashed line, then D dash to A dash dashed line, then D dash to D1 dash dashed line. So remaining diagram. So this completes the problem, and finally we have an axis. Okay, so this completes the problem. So we can like the video, subscribe, and press on the bell icon. Problem from the CAD solution book. So the problem was, it is on hexagon. So hexagon, it is nothing but a cube. Hexa means 6, hedron means faces. So 6 equal faces we can find only in the cube. Okay, so it is a cube of dimension 30 mm resting on one of its corners. So first position starts from the corner, and here you can see one of the solid diagonals. So we have to make use of the solid diagonals, so which is there in the cube. So is perpendicular to VP. Okay, perpendicular to VP. So that means when they have mentioned the third position, and in the second position we are going to make it parallel to VP and then perpendicular to VP. Second position parallel to VP, third position perpendicular to VP. So now we will see the problem. So now we have to construct a square of dimension 30 here. So for that, first I will take reference point here. Reference point of 145-degree marking. Now I'm drawing a line of length 30. Okay, here also. So 30 using compass. Okay. Now we can join here. So this is A1, B, B1, C, C1, D, D1. So inside lines will be thin lines because it is an prism. Okay. Please move on. So okay. So it is 30 here also. Okay. So dimensions we can show on one side here. So dimension we have 30, and here also it is 30. Okay. We write the notations here. A dash visible, B dash visible, C dash visible, but D dash not visible. Okay. Same case A1 dash, B1 dash, B1 dash not visible, C1 dash in here, O1 dash and O dash. So now I'm drawing in solid diagonal. Okay. So I'm going to check this angle, how much it is. I want to make it parallel, right? So for that I'm going to check this angle. It is exactly 35 degree. Okay. So 35 degree I'm taking here. Reference of here A1 dash. Okay. And here exactly I'm marking at 35 degree and drawing a line of length. With my compass I have to do so this is C1 dash and this one over here. This point P1 dash and T1 dash. This is O1 dash. Now marking at 90 degree. Now straight line you have to draw. It's 30. Yeah, 30. Here also we have 30. Okay. You can see that here straight line. This is A dash, B dash, and D dash in bracket, C dash, and O dash. Now projecting the lines vertically downward. So you can write A, this is B, this is C, and D. Same case here. So you can write this is A1, B1, C1, C1, and here we have O, and this point O. Now we construct outer boundary line first. So now you can see that the top face, it is visible from the top view. So that means this at C dash and C1 dash, it is visible. Now the bottom face, it is not visible from the top view. Okay. Okay, so this is we are done, and part of the axis I'm showing here. Now, so this is a solid diagonal which is now parallel to VP. I'll make it perpendicular to VP. How to do that? Take reference of C1 now here. Now measuring from this length. So I'm going to cut dark. So here I'm going to draw a straight line. Okay. Now I'm cutting the arcs. Okay, so this point we have C and O1, this is O and A1, and this is A. Now using compass we have to construct the squares here. Same thing here also. So we are going to join it. Of the dashed line. Now final position, so we are going to do this is C1 dash. So namings we have to write this is D1, this is D, B. Okay. Now projecting this D1 here. This is B1, D1 dash, B1 dash, and this point here B1 dash, and this is O1 dash. C dash, B dash, C dash and C B dash C dash. Okay, nearest point x value it is C1. Okay, C1 it is connected with D1, C1 connected with B1, C1 connected with C. Okay, so these are the dashed lines. That is from C1 to C1 dash to D1 dash, C1 dash to D1 dash, C2. Okay, C dash line. Now remaining lines will be written with the continuous lines. Okay, so this completes the problem. So you can like the video, subscribe, and press on the bell icon for the new upcoming videos on the solid edge. Problem from the CAD solution book, that is problem number 45. So it is a cone problem. So for the cone they have given 50 mm base diameter and axis length 60, and it is resting on one of its generators, like slant edge and slant triangular face problem. And then draw its projections when the axis, so they have given angle of inclination to axis means, so it is an beta angle problem. So what we have to do in this problem is, first we have to construct a line. Okay, and then you have to draw a circle and divide that circle into 8 equal parts. Okay, so first we have to draw an XY line. Okay, VP HB Y, and we take a compass, and here, so diameter 50 means you have to take a radius of 25. Okay, radius of 25, take it, and draw a circle of diameter 40. Now we are going to divide this circle into 8 equal parts. So now it is divided into 4 parts, right? So to divide into 8 equal part, so mark at 45 degree here and 45 degree here. Okay, I can extend it. Show the dimensions on one side. So it is 50. Okay, now projecting it. So the axis length we have 60. So these lines has to be thin lines. Okay. So now write down the notations. A dash, B dash visible, H dash not visible, C dash, D dash not visible, D dash and F dash not visible, and E dash, and here O1 dash and O dash. So So the axis length we have here, it is 60 mm. Okay. So now it is resting on the generators. So take E dash, measure from E dash to O dash. Okay, measure it and then cut the arc. So this is O dash. Next point, it is measuring from E dash to E dash. Okay, here from here O dash to dash. This is E dash. Okay. So we have to cut the arcs here now. So the namings we can write B dash, H dash, and this is 1 dash, C dash, G dash, and this is we have D dash and F dash. So this is an axis. This is thin lines. Okay, now projecting downward, so we can complete the problem. Okay. So here we have E dash, and this point it is D dash, and this it is C dash, and this point we have B dash, this is E dash, and this is the H dash, and this is G dash. This finally we have U dash. Okay. So we will first we construct. So this point it is 1 dash. First we construct an ellipse. Okay. And finally we have an axis, so we will show an axis here. Okay, so now it is an beta angle problem. Okay, so mark at 30 degree. Marked. First I will take a reference point of O here, measuring the length of axis 60 here. This is O2. Again measuring from this length. This is 1. So this is the first axis length, and the second axis length we have to measure. Okay, for beta angle. Okay, now you have to join it. and find out the angle. Here we get it around 33 degree. Okay, now I am going to extend this line. Okay, the same line we have O1 to A1. Okay, so this point we have is E. So this all written in E. Okay, so next thing it is cutting the arc. So we have this is F and this H, this is D, this is E. G, this is C. So okay, so it is done. So it is first one, it is O dash. O dash is O dash. C dash and we have E dash, F dash, G dash, H dash. Okay, finally we have O1 dash. Okay, okay, finally we have an axis. So this completes the problem. So like the video, share it, subscribe and press on the bell icon for the new upcoming videos. Do next problem. It is problem number 44 from CAD solution book. So this problem on a tetrahedron. We have to construct a tetrahedron of dimension 55, rest with one of its corners. Okay, such that an edge containing that corner is inclined to HP at 650 degree and VP at 30 degree. You can see that the same edge has been inclined with respect to both HP and VP as it is same as that of your beta angle, wherein we find the axis has been inclined to both HP and VP. Here the same edge has been inclined to HP and VP, so that's why this is also an beta angle problem. Okay, beta angle problem, because the same edge has been inclined for both HP and VP. Okay, now we will construct. Tetrahedron. So dimension 55 you have to take. Dimension 55, taking from compass. Okay, so now we have to draw the medians here. So now we are going to erase these edges. Okay. So we constructed a tetrahedron of dimension 55. Okay. Given ABC, O1. Okay. Projection line. Now here in the question they have not mentioned the axis line, just we draw a straight line. So the procedure here, we have to consider 55 mm length. Okay, 55 mm length from this side. This is the end OC, it is parallel. From the parallel end side we have to cut an arc here. Okay, from this end parallel end we have to cut the arc, then join it. So here naming C dash in bracket, B dash, C dash, O1 dash, O dash. Now second angle of inclination, it is there with the edge containing. This is the edge which is containing the corner. That means we have to incline this at an angle of 50 degree. So I'll be taking the reference of here A dash, and here I'll be marking at an angle of 50 degree.
ये मंथ का जो एग्ज़ाम ड्यूटी है वो आपके पास लिस्ट है क्या, फोटो लिए हैं क्या?
बाद में भेज दो वीडियो को. So we have to cut an arc here. Okay, so this is C dash from here to here. So this is O dash from here to here. So we have to cut the arcs here. This is O1 dash. This is A dash and B dash. Okay, so here this is having an angle of 50 degree. Now project it downward. Okay, so this point here A, this is B, this is C, this is O1 and this is O. First we construct an outer boundary line here, B to O, then O to B. Okay, so this forms an outer boundary line. Now AB what is done. You can see this base of this tetrahedron not visible from the top view, so that's why dashed line. In part of the axis, so we can show here. Okay, now so this length it is 55, right? This first length, and this is we have second length. Taking these two, we have to move the beta angle. So angle of inclination it is 30 degree. The first point we could take O, measuring from here O to C. So this is C2. Draw the locus. Then measuring from O to C. So in this problem we have to consider the edge length. You can see that C to O and O to C. So these two lengths I'm considering. Okay. Join this. And extend. So the angle will be cutting around here. It is 50, 51, 52 degree you get. Okay. So this is what the beta angle. Now we have to transfer the diagram here. Measuring from C to O1. This is O1, this is C. Now using compass C to A. The next O to A. So this point it is A and this point it is B. Okay, now we can join it. Okay, so now extend it to complete the final diagram. So it is O dash, and here we have C dash, O dash, B dash and this one we have O1 dash. So the concept here is we have to construct the base of the tetrahedron. The base of the tetrahedron is a triangle. So first we are going to construct that. Okay. So now the slant ranges from C dash to O dash is continuous line. From B to also continuous line, but from A to O it is passing inside. That's why it is dashed line. And then finally we have an axis. Okay, so this completes the problem. So you can like the video, subscribe and press on the bell icon. Problem number 50 from CAD solution book. So in this problem they have given a cone base diameter 40 and axis length 50 resting on HP and a point on the circumference of its base such that its apex is at a 40 mm above HP. So they have not mentioned angle of inclination to HP. Instead of that they are telling its apex is at a distance of 40 mm above HP and the top view of the axis is inclined at 60 degree. You can see that they have mentioned here top view, that means no beta angle. So we have to proceed with the solution here. Here we have a circle, diameter 40 means, so we have to consider 20 here. So we have to divide the circle into 8 equal parts. Marking at 45 degree and here 35 degree. Axis length of 50 here. Dash, B dash, H dash, C dash, G dash, D dash, E dash, this is O1 dash and O dash. That is 50. Okay. Now here 40 mm vertical length we have to take. So first here I have to take B dash, measuring from compass, we have to put the mark. Dash. We're going to extend downward. Okay, now we have to write the notations here. This point is B and this point is C. This is D, E, F. This is H, this is O, so I have to draw on my ellipse here. Marking at 60 degree. This is the reference point of 4. And it's moving forward. Back here. We have V, O1 and U. What is it yours? And positions. So this completes the problem. Okay, today we are going to start problem number 43 from CAD solution book. Okay, it's a cube problem. So the dimension is given 40 mm side, rest one is on an edge. So which is inclined to VP at 30 degree. Draw the projection in the lateral square face containing the edge on which it rests makes an angle of 50 degree. First we have to construct a square of dimension 40. Okay, we will draw thin lines here to connect the center of the axis. Give the naming A, B, C, D, top face A1, B1, C1, D1, O, O1. Front view we getting this, front view also 40 mm. B dash, A dash in bracket, C dash, D dash in bracket. Similarly A1 dash, B1 dash, C1 dash and D1 dash, E1 dash, and this is O dash. Lateral square face containing 58 means we have to do base edge inclination here. Base edge inclination is equal to 90 minus 40, that is 40 degree. So here can take a reference point of C1 dash and D1 dash. Here marking at an angle of 50 degree. Measuring the length from here to here. Cut the arc. This is A1 dash, B1 dash. So this is O1 dash. Okay. Now we will be marking at 90 degrees. So we have to draw a line of length 30 here, 540. So we can join here. is B dash, A dash, this is O dash, C dash, and D dash. So if we extend the axis, find out the angle of inclination here exactly 50 degree. Okay. So now projecting downward, so we can write here this is V1, B1, C1, D1, this is O1. Similarly we have this is A, this is B, this is C, this is D, and this is O. So first we construct an outer boundary line here. Outer boundary line we are constructing. This top face, it is visible, ABCD top face. Okay, the bottom face here it is C1 and D1 not visible from the top view, so that's why D1 and C1 it is in bracket. And finally we have an axis, so we are showing it. Now inclination to VP here 30 degree. So take a reference point here, mark for 30 degree. You have to take this reference point of D1. From D1 to C1, cut the arc. So this is dashed line. We'll be showing with the dashed line. Okay. So now suppose these points and be marking it exactly 90 degrees on either side. So now we are going to cut the arc. So we can join it. So this is A, B, this is A1, B1, so this is D, this is C. is O1 and this is O. So this remaining thing we are going to rub it. D dash, this is C dash. O dash. Okay, finally the bottom face. This is 1 dash and this is we have B1 dash, B1 dash, this is D1 dash and this is C1 dash. So okay, we take a nearest point. So nearest point actually it is D here. So D connected with C, D is connected with A, D is connected with D1. So these are the dashed lines. Okay, so understood, right? So from D to C, that is from D dash to dashed line, then D dash to A dash dashed line, then D dash to D1 dash dashed line. So remaining diagram. So this completes the problem, and finally we have an axis. Okay, so this completes the problem. So we can like the video, subscribe, and press on the bell icon. Problem from the CAD solution book. So the problem was, it is on hexaedron. So hexaedron, it is nothing but a cube. Hexa means 6, hedron means faces. So 6 equal faces we can find only in the cube. Okay, so it is a cube of dimension 30 mm resting on one of its corners. So first position starts from the corner, and here you can see one of the solid diagonals. So we have to make use of the solid diagonals, so which is there in the cube. So is perpendicular to VP. Okay, perpendicular to VP. So that means when they have mentioned the third position, and in the second position we are going to make it parallel to VP and then perpendicular to VP. Second position parallel to VP, third position perpendicular to VP. So now we will see the problem. So now we have to construct a square of dimension 30 here. So for that, first I will take a reference point here. Reference point of 145-degree marking. Now I'm drawing a line of length 30. Okay, here also. So 30 is encompass. Okay. join here. So this is A1, B, B1, C, C1, D, D1. So inside lines will be thin lines because it is an prism. Okay. Please move on. So okay. So it is 30 here also. Okay. So dimensions I can show on one side here. So dimension we have 30, and here also it is 30. Okay. We write the notations here. A dash visible, B dash visible, C dash visible, but D dash not visible. Okay. Same case A1 dash, B1 dash, B1 dash not visible, C1 dash in here, O1 dash and O dash. So now I'm drawing in solid diagonal. Okay. So I'm going to check this angle, how much it is. I want to make it parallel, right? So for that I'm going to check this angle. It is exactly 35 degree. Okay. So 35 degree I'm taking here. Reference of here A1 dash. Okay. And here exactly I'm marking it 35 degree and drawing a line of length. With my compass I have to do so this is C1 dash and this one we have this point P1 dash and T1 dash. This is O1 dash. Now marking at 90 degree. Now straight in here to go. It's 30. Yeah, 30. Here also we have 30. Okay. You can see that here it is straight line. This is A dash, B dash, and D dash in bracket, C dash, and O dash. Now projecting the lines vertically downward. So we can write A, this is B, and this is C, and D. Same case here. So we can write this is A1, this is B1, C1, C1, and here we have O, and this point O. Now we construct outer boundary line first. So now you can see that the top face it is visible from the top view. So that means this at C dash and C1 dash it is visible. Now the bottom face, it is not visible from the top view. Okay. Okay, so this is we have done, and part of the axis I'm showing here. Now, so this is a solid diagonal which is now parallel to VP. I'll make it perpendicular to VP. How to do that? Take reference of C1 now here. Now measuring from this length. So I'm going to cut dark. So here I'm going to draw a straight line. Okay. Now I'm cutting the arcs. Okay, so this point we have C and O1, this is O and A1, and this is A. Now using compass we have to construct the squares here. Same thing here also. So we are going to join it. Of the dashed line. Now final position, so we are going to do this is C1 dash, so namings we have to write this is D1, this is D, this is B. Okay, now projecting this D1 here. This is B1, D1 dash, B1 dash, and this point here B1 dash, and this is O1 dash. C dash, B dash, C dash, and C B dash, C dash. Okay, nearest point X value it is C1. Okay, C1 it is connected with D1, C1 connected with B1, C1 connected with C. Okay, so these are the dashed lines. That is from C1 to C1 dash to D1 dash, C1 dash to D1 dash, C2. Okay, C dash line. Now remaining lines will be written with the continuous lines. Okay, so this completes the problem. So you can like the video, subscribe, and press on the bell icon for the new upcoming videos on the solid edge. So it is a problem number 46 from CAD solution book. It is a problem on tetrahedron. So we see in this problem a tetrahedron given of sides 40 mm rests on one of its sides on HP, okay, with respect to the right hand side. So you need to consider the edge. This side is parallel to VP and 40 mm away from it. So we have to make that side parallel to VP and 40 mm away from it. It is the third position. It is tilted about the resting side such that base containing this side is inclined at 30 degree to HP. So that is, so base edge inclinations they have directly given. Okay. So base edge inclinations directly given. No need to find out separately here. So first it is an extra line here. So it's VP, HP and Y. So here we have to draw an tetrahedron of sides 40. So dimensions 40 here. So tetrahedron means it is a pyramid. Okay, so tetrahedron is a four triangular pyramid. Four triangular face pyramid it is. So now after drawing a triangle, we have to take exactly the middle points. Okay. So to draw the medians here first, we have to draw the medians. So after this, we have to retain only the slant edges. Okay. Right here A, this is B, this is C, O, O1. So here, so we can take further dimensions on one side. This is 40. Now we draw the front view. So here, we don't know how much axis length is, so we draw like this. Now from this end we have to take length of 40 and we have to cut there, because this edge we have to see this edge, one of which end which is parallel to xy. So from that side we have to cut there. So remember it. So here this AO, this edge is slanted parallel to x. So that's why we are cutting from this end. So measuring 40. So cut there. So this is A dash, this is O1 dash, this is O dash, B dash and C dash in bracket. Okay. So you can show dimension here. So this is 40. Okay. It's 40. Now we have to take this and this B dash and C dash we have to take, and here base edge inclination directly we have to do for 30 degree. You can see that 30 degree HP. Okay. So we draw a line of length. So after this we have to cut the, okay, from here to here. Okay, so this is A dash, this point over here, one dash. After that, okay. projecting downward. This point will be here. This point you will see, and this is 0. This point it is 1. So first we are going to construct the outer boundary line. Okay. So this is the outer boundary line. Now we are able to see this A dash, O dash end. So that is A to O continuous line. But the base of the tetrahedron not visible. So that's why you can see here. So it is written with the dashed line here. Okay. So dashed line. So now you can see from this, and this side is parallel to BP and 40 mm away from it. We have to make it parallel means, so we'll take CB here, draw, but it is at a distance of 40 mm. So what I will do, I will draw here a line of length 40. So from this end we'll take C, marking from C to B. We can cut there. This is CB. Measuring from C to O. So B2 also same it is. Okay, B2 also same it is. After that B to A, and C to A. So these two lines will be same. Next we have B to O1. Next C to O1. So this is A and this is B1. Now we have to join. Okay. So we join from this angle. Now projecting upward, we have to complete the final position here. Okay. So see, it is matching here C dash, C B dash, and this point we have O1 dash, C we have O dash, and A point we have this. So we know the concept in writing pyramids. First we have to construct the base edge here. Okay, so the base edge we have A dash, C dash, and B dash, connecting it. Okay, so this is we have to connect. Now the slant edges. Okay, slant edge from C dash to O dash, and B dash to O dash, and finally we have from A dash to O dash. So part of the axis I am going to show here. Okay. So this completes the problem. So you can like the video, subscribe for the channel, and hit on the bell icon. Do next problem. It is problem number 44 from CAD solution book. So this problem on a tetrahedron. We have to construct a tetrahedron of dimension 55, rest with one of its corners. Okay, such that an edge containing that corner is inclined to HP at 650 degree and VP at 30 degree. You can see that the same edge has been inclined with respect to both HP and VP as it is same as that of your beta angle, wherein we find the axis has been inclined to both HP and VP. Here the same edge has been inclined to HP and VP, so that's why this is also an beta angle problem. Okay, beta angle problem, because the same edge has been inclined for both HP and VP. Okay, now we will construct. Tetrahedron. So dimension 55 you have to take. Dimension 55, taking from compass. Okay, so now we have to draw the medians here. So now we are going to erase these edges. Okay. So we constructed a tetrahedron of dimension 55. Okay. Given ABC, O1. Okay. Projection line. Now here in the question they have not mentioned the axis line, just we draw a straight line. So the procedure here, we have to consider 55 mm length. Okay, 55 length from this side. This is the end OC, it is parallel. From the parallel end side we have to cut an arc here. Okay, from this end parallel end we have to cut the arc, then join it. So here naming C dash in bracket, B dash, C dash, O1 dash, O dash. Now second angle of inclination, it is there with the edge containing. This is the edge which is containing the corner. That means we have to incline this at an angle of 50 degree. So I'll be taking the reference of here A dash, and here I'll be marking at an angle of 50 degree.
ये मंथ का जो एग्ज़ाम ड्यूटी है वो आपके पास लिस्ट है क्या, फोटो लिए हैं क्या?
बाद में भेज दो वीडियो। So we have to cut an arc here. Okay, so this is C dash from here to here. So this is O dash from here to here. So we have to cut the arcs here. is O1 dash. This is A dash and B dash. Okay, so here this is having an angle of 50 degree. Now project it downward. Okay, so this point here be A, this is B, this is C, this is O1 and this is O. First we construct an outer boundary line here, B to O, then O to B. Okay, so this forms an outer boundary line. Now AB, what is done? You can see this base of this tetrahedron not visible from the top view, so that's why dashed line. Can part of the axis, so we can show here. Okay, now so this length, it is 55, right? This first length, and this is, we have second length. Taking these two, we have to move the beta angle. So angle of inclination, it is 30 degree. The first point we have to take O, measuring from here O to C. So this is C2. Draw the locus, and then measuring from O to C. So in this problem we have to consider the edge length. You can see that C to O and O to C. So these two lengths I'm considering. Okay, join this. And extend. So the angle will be cutting around here. It is 50, 51, 52 degree you get. Okay, so this is what the beta angle. Now we have to transfer the diagram here. Measuring from C to O1. This is O1, this is C. Now using compass, C to A. The next O to A. So this point it is A and this point it is B. Okay, now we can join it. Okay, so now extend it to complete the final diagram. So it is O dash, and here we have C dash, O dash, dash and this one we have O1 dash. So the concept here is we have to construct the base of the tetrahedron. The base of the tetrahedron is a triangle. So first we are going to construct that. Okay. So now the slant edges from C dash to O dash is continuous line. From B to also continuous line, but from A to O it is passing inside. That's why it is dashed line. Okay. And then finally we have an axis. Okay, so this completes the problem. So you can like the video, subscribe and press on the bell icon. Problem number 50 from CAD solution book. So in this problem they have given a cone base diameter 40 and axis length 50, resting on HP and a point on the circumference of its base such that its apex is at a 40 mm above HP. So they have not mentioned angle of inclination to HP. Instead of that they are telling its apex is at a distance of 40 mm above HP, and the top view of the axis is inclined at 60 degree. You can see that they have mentioned here top view, that means no beta angle. So we have to proceed with the solution here. Here we have a circle, diameter 40 means, so we have to consider 20 here. So we have to divide the circle into 8 equal parts. Marking at 45 degree and here 35 degree. Axis length of 50 here. Dash, 3 dash, H dash, C dash, G dash, E dash, E dash, this is 1 dash and 1 dash. That is 50. Okay. Now here 40 mm vertical length we have to take. So first here I have to take E dash, and measuring from compass, so we have to calculate. E dash. We're going to extend downward. Okay, now we have the notations here. BA, this point is B and this point is C. This is D, E, F. This is H, this is O. So I have to draw on my lips here. Marking at 60 degree. This reference point of 4 and zoom from we have U, O1 and U. What is it reverse? And positions. So this completes the problem. So it is a problem number 48 from CAD solution book. So in this, a pentagonal prism of base side 25 and height 50 resting on HP with one of its base corners, such that the topmost edge is at a distance of 60 mm above HP. So they have not mentioned angle of inclination to HP. Instead of it, they mention the topmost edge is at a distance of 60 mm above HP when the top view of the axis is inclined at 45 degree to VP. So they mention here not only the axis, they mention top view. So that means no beta angle. And find the inclination of the longer edge of the prism to HP, which contains the resting corner. So first we have to draw an XY line here. So VP, HP, Y. So first we have to construct pentagon of dimension 25 with respect to the corner, base corner we have to get on the right hand side. The angle we give here, that is 72 degree. And drawing a line of length 25 mm passing through that angle point. And again here also we are going to mark at 72 degree and drawing a line of length 25. Now taking compass, we will cut the arc of dimension 25. So we can give the naming A, B, C, D, E. Okay. So we have to find out center of the bottom face. We have A1, B1, C1 and D1. So this bottom face not visible, that's why it is written in brackets. So marking the middle points to draw the medians. So perpendicular bisectors here. So here the perpendicular bisectors will be drawn in thin lines because so it is a prism. So we mark the center points O1. Now we draw the projection line to complete the front view. So front view axis length height is 50. The front view of a prism is a rectangle. Now we are marking front view notations. Okay. So dimension it is 25. Length, axis length is 50. Top face notations. Now bottom face notations. You see, topmost edge is at a distance of 60 mm above HP. So first I am going to take a reference point of D1 dash. I'm drawing vertical line of length 60 and drawing the locus. So we have to measure from D1 dash to B1 dash. That is what the topmost edge. So measuring that length. So we have to cut the arc. So that is B dash, E dash. So herein we have to give the inclination to the right side. Okay, right side inclination we are following it. That's why we am cutting the second arc there. So we will neglect the first arc because we have to make sure our inclination has to be there on the right hand side. Okay. So that particular point is B dash, A dash. So we can join. So this is what the point we have considered. Now just joining it. So now using compass we have to construct this position. You have to copy it. D dash, that is. So join. You have to cut it from again bottom face D1 dash to A1 dash. So cut the arc. Then B dash to A1 dash. So cut the another arc. So join it.
ಸ್ಟಾಪ್ ಮಾಡಿ ಸ್ಟಾಪ್ ಮಾಡಿ.
Now we have to cut the arc, so we have to copy it using compass. So we have to cut it. Join now. So there is an axis line we have to join here, and there is a continuous line. We have to write down the notations. So we can extend the axis and we will find out this is the inclination of the longer edge of the prism. Okay, so here we're getting around 36 degree I think. The 3-degree inclinations. Okay, now we have to project it downward to complete the second position, top view. You have to project it from both top side and sideways both. You have to draw the projection lines. Now we have to write down the notations here. First we are writing for the bottom face. It is A1, B1, bottom face notations. Now top face notations. Okay, now the first step in writing second position top it is writing the outer boundary line. Okay, that's what we are doing now. Writing the outer boundary line. Now after this, writing the visible faces, the top face, top pentagonal face visible. So that's why continuous line to construct a pentagon here. Okay, now that rectangular face also visible from the top view. Okay, now the bottom face not visible. So that's why part of the pentagon will be written in the dashed line here. Okay, now the bottom edge DD1, so it is going to be written with the dashed line, part of the axis. So now angle of inclination to VP we have 45 degree. So it is angle of inclination to axis. Okay, the top view of the axis is inclined to VP by 45 degree. So we have to make sure our third position should not merge with the second position. Okay, drawing the angle line. So take the reference point of D. Now from measuring from D to O1, then D to D1, measuring from compass, cutting the arc, then finally from D to O. On the same line we have these points. Okay, D to O, this is D1 and this is O1. Okay, using these 2 points we can construct the pentagons. Okay, first we are going to construct the pentagons. It is D1 to E1 and D1 to C1, and this length it is exactly same to the D to C and D to E. Okay, then from O1 to E1 and O1 to C1 will be same. O1 to E1 and O1 to C1. From here also O to C and O to E. Okay, so thus that length will be same. So we are going to write it. This is E1, this is C1, this is E, this is C. Now again measuring from D to E, D1 to A1 and D1 to B1. So those 2 lengths will be same. So measuring only one length. Again from D to A and D to B. So now we have to join it. So now we are going to join. So join all the, where are the dashed lines with there. So draw with the dashed lines. Where there is a continuous line, show with the, draw with the continuous line. Okay, so first we are constructing a pentagons. Okay, Now we can see that nearest point to xy line it is E, so we will write it E point. So E it is near adjacent to D point, and E it is near to adjacent to A point, and E is adjacent to E1, E to A and E to E1. So these are the dashed lines. Okay. Now first we write the notation for the top face. Top face in both, we consider top face in front view, top face in top view, and writing the notations. Now for the bottom face we write the notations. First we write the dashed line, that is from E dash to D dash, and E dash to A dash, and E dash to E1 dash. Okay. First we are going to draw the dashed lines. Now we construct the pentagons. Okay. Pentagons. Now drawing the vertical edges from A dash to A1 dash, B dash to B1 dash, C dash to C1 dash, and D dash to D1 dash. Okay, finally there is an axis from O1 dash to O dash. From O1 dash to O dash. So we have to join. Okay, so that completes the problem. So for more videos you can subscribe for this channel and hit on the bell icon and share the videos for the needy students. Okay, so it is one of the special type of problems in projection of solids. Okay, so it is a unique type of problem, so it will be helpful.